In this video, I'm going to talk to you about the convexity adjustment, which obviously comes from the fixed income section of the CFA Level 1 curriculum, an important and often tested item. So if this is something you want to get right in the exam, do keep watching and let's get solving. So this is the question which I want us to have a go at. A bond has an annual modified duration of 4.68 and an annual convexity of 54.46. If the bond's yield to maturity increases by 25 basis points, the expected change in the value of the bond is closest to, and we've got three options, all of them are negative, pointing to the fact that the expected change is actually a drop in response to yields or rates going up. So how do we actually go about forecasting or predicting the magnitude of change in terms of a response in bond price to changes in rates or yields to maturity? Well, one relationship you should be already familiar with from your earlier studies of fixed income, hopefully, is the following. There is a convex relationship between bond price and the level of rates, which we will assume to be equal to yield to maturity. Now, if this is a starting point, so the initial level of rates is or yields some kind of yield 0, whatever it may be. And in this question, we're not even given a starting point. We're just told about what the change is. And this is the initial price. Then obviously, if yields go up to a new level, let's call this Y1, new level of yields, the bond will drop in value to some new level P1. And in this question, we're told about the fact that yields actually are going up by 25 basis points, BPS. So that's 0.25%. Now, obviously, the opposite thing happens when yields go this way. And let's call this yield 2. And we're going to have a new level of price. Let's call this P2. Now, one thing to definitely take into account and know is the fact that in response to a yield increase, bond prices drop, but in response to the same magnitude of yield drop, bond prices increase by more. And that's due to the convex nature of this relationship. Now, how do we, once again, go about computing the percentage change in price, which is what we're asked about? Well, there are two things we need to take into account. One is the so-called duration effect. And in order to compute this, we're going to obviously use the modified duration parameter from up here. And on top of this, we're going to have a second effect called the convexity effect or convexity adjustment. Let's call this the convexity effect. Okay. The duration effect is a first order approximation. That's how people often call it. Because what duration does is it tries to predict, okay, quite happy with this tangent line here, what will happen when yields go down or yields go up, but it's a linear relationship which doesn't take into account the convex nature of this true relationship of rates and price. So when you compute the expected change in bond price due to the duration effect alone, you're going to end up over here in terms of the forecast price change or new price. So let me call this or say that this is the price or new price, obviously new bond price, as predicted or as forecast by duration effect alone. if the relationship between rates and bond price were indeed linear, this would be the point. However, the new price point. However, it's not linear, it's convex, and hence this second effect, the convexity effect, which takes account of, well, in both cases, up and down moves to rates, the fact that we are actually going to end up more precisely here. And this is the point we want to get to. Now, what is the formula? In terms of duration effect, this is something you should probably already know, because in order to apply the duration effect or predict the change in bond price due to the duration effect, what you've got to do is take the negative of modified duration, so that's going to be a negative 4.68, and multiply this by the change in yields or change in rates, which in this case is 25 basis points. So I'm going to say times change in yield. And obviously, I'm going to leave space here for the convexity effect. But if we try to compute this very quickly, we're going to have a negative 4.68. I took the duration. Let's multiply this by 25 basis points, which is basically 0.25% or 0.025 if we express this as a decimal. And if we do this, let's switch to the calculator. So 4.68 modified duration, let's put a negative sign in front of it with the plus minus key, multiplied by 0.0025. And I can see a negative 0.0117 from over here, from this computation. So negative 0.0117, and this would actually be synonymous with an expectation of a 1.17% drop in value. But this is the duration effect alone. In reality, if we take the convexity effect into account, whatever it is, things can only get higher, or the expected price will actually be higher. So the drop will, in fact, the predicted drop will not be as severe as this. So this is the new price as predicted by both the duration effect and on top of it, the convexity effect as well. And as I said, the drop will be less severe than 1.17. And if you look at the possible answers to the question, there's only one single answer which satisfies this condition, that the drop is less than 1.17%, and that is answer B, which actually says 1.15%, doesn't it? So I've already answered the question. I don't need to go any more. And in the same way, if you were asked about, the predicted change in bond price in response to a drop in yields or drop in rates, you could calculate what duration predicts, or what is predicted based on duration alone, and then come to the conclusion that in reality, once you take the convexity effect into account, it has to be a little bit higher. So the convexity adjustment is always an upward adjustment in terms of predicted price or a forecast change in bond value. Now, I do want to take this further. I do want to complete the question and do this properly, even though I know the answer should come in at 1.15, which was answer B, and tell you how to do this convexity adjustment. It's a little bit more complicated, because what you've got to do here is take half of whatever the convexity parameter is, and this ought to be multiplied by the change in yield squared. Okay, so that is the convexity effect, and yes, it is slightly more complicated, and in reality, you won't always need to compute it. Just like here, you can answer the question without actually doing this, but let's do it anyways, for practice sake. So the convexity parameter is 54.46 in this question, so I'm doing plus half of 54.46 times the change in yield, which was 0.0025. So this is the same number as over here. And obviously I'm going to square this, and let's see what we get on the calculator. I'm going to start from the end, 0.0025, square this, times 54.46, times 0.5. And okay, this comes in at an absolutely positive 0.00017. Now, obviously, there's a little bit more hanging at the end, but I'm not going to put that down. So let's take these two effects together, combined. I've still got my 0.0017, and that's a positive figure, minus 0.0117. The answer, which I'm looking at, is a negative 0.0115. And let me express this as a percentage. That's going to be a negative 1.15, obviously point something percent, 1.1529 or 3. But when we round this to two decimal places, it's 1.15%, which is absolutely what we already had written down as answer B.